So students, again we are continuing with the current electricity. Our chapter name is what? Current electricity. Current electricity. Our chapter name is current electricity. Let's see next problem. An electric power station of 100 megawatt transmits power to a distant load through long and thin cables. Which of the two modes of transmission modes of transmission would result in lesser power wastage. So, രണ്ട് രീതിയിൽ പവർ ട്രാൻസ്മിറ്റ് ചെയ്യുന്നുണ്ട്. പവർ ട്രാൻസ്മിഷൻ ഓഫ് 20,000 volt, first one 20,000 volt, or second one 200 volt. 20,000 volt or 200 volt. Okay, which one of the method you should follow? See, question Malayalam nula. ഒരു ഇലക്ട്രിക് പവർ സ്റ്റേഷനിൽ 100 മെഗാവാട്ട് പവറാണ് ട്രാൻസ്മിറ്റ് ചെയ്യുന്നത്. ഇപ്പൊ ട്രാൻസ്മിറ്റ് ചെയ്യുന്ന പവർ എത്രയാണ്? 100 മെഗാവാട്ട്. ഡിസ്റ്റന്റ് ലോഡ് അകലെയുള്ള ഒരു സ്ഥലത്തോട്ട് ത്രൂ ലോങ് ആൻഡ് തിൻ കേബിൾസ്. വിച്ച് ഓഫ് ദ ടു മോഡ്സ് ഓഫ് ട്രാൻസ്മിഷൻ വുഡ് ബി റിസൾട്ട് ഇൻ ലെസർ പവർ വേസ്റ്റേജ്? പവർ വേസ്റ്റ് കുറയ്ക്കാൻ ഏതാണ് നല്ല മെത്തേഡ്? ഏതൊക്കെയാ? രണ്ട് മെത്തേഡ് എത്രയാ? ഏതൊക്കെയാ? ഒരെണ്ണം 20,000 വോൾട്ടിലും ഒരെണ്ണം 200 വോൾട്ടിലും. നമുക്ക് ഇതിന്റെ ആൻസർ ഓൾറെഡി അറിയാം. കാരണം വൈ വി സെൻഡ് ഇലക്ട്രിസിറ്റി അറ്റ് ഹൈ വോൾട്ടേജ് എന്ന് പറഞ്ഞൊരു ക്വസ്റ്റ്യൻ നമ്മൾ ഞാൻ പഠിപ്പിച്ചിട്ടുണ്ട്. നിങ്ങൾക്ക് അറിയാം എന്തിനാ നമ്മൾ ഹൈ വോൾട്ടേജിൽ ഇലക്ട്രിസിറ്റിനെ സെൻഡ് ചെയ്യണേ? ടു റെഡ്യൂസ് പവർ ലോസ് കുറയ്ക്കാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ഹൈ വോൾട്ടേജിൽ ഇലക്ട്രിസിറ്റിനെ സെൻഡ് ചെയ്യണേ. അപ്പോൾ നമ്മൾ ഇതിൽ പ്രിഫേർഡ് ചോയ്സ് എത്രയാ? 20,000 വോൾട്ട് ആണ്. അത് നമുക്ക് എല്ലാവർക്കും ആദ്യം അറിഞ്ഞിരിക്കണം. അപ്പോൾ നമുക്ക് ഇക്വേഷൻ വൈകി സോൾവ് ചെയ്തിട്ട് ആദ്യം മനസ്സിലാക്കണം. ശ്രദ്ധിക്കുക, ഇവിടെ നിങ്ങൾ മനസ്സിലാക്കേണ്ടത് ഏത് മെത്തേഡിലാണ് ഹീറ്റ്, അതായത് നമ്മുടെ ഈ ഹീറ്റ് ഡിസിപ്പേഷൻ, എത്രത്തോളം പവർ കൺസ്യൂംഡ് പവർ will be high in which method. So that is our problem. So let's see. In the first case, power is 100 megawatt, and what is the voltage? 20,000 volt. 20,000 volt. First of all, you should find out the resistance of the cables. So what is the resistance of the cables? That we should know. So in order to get the resistance, we know that power is equal to, what is the formula? What is the formula for power? Power is equal to VI. We know that formula, power equal to VI. So I is equal to what? T by V. What is the power here? 100 into 10 raised to 6 divided by, what is the voltage? Voltage is what? 20,000. That is 100 into 10 raised to 6 divided by 20 into 10 raised to 3. So 100 by 20 is what? 5. 10 raised to 6 divided by 10 raised to 3 means what? 5 into 10 raised to 3. So that means what? 5000 ampere. See, this much current is coming in the first case. So what will be the power consumed? Power consumed is equal to what? I squared R. So I squared R means what? 5000 square into R, which is 5000 square means what? 5 into 10 raised to 3 the whole square into R. What is that? 25 into 10 raised to 6 into R. 25 into 10 raised to 6 into R. This much watt is consumed in the first case. See, again I am reminding you. Yeah, all of you, good afternoon. Good evening. Again I am reminding you, what is the case here? We have to send how much power? 100 megawatt to a long distance load through cables. നമുക്ക് 100 മെഗാവാട്ട് ഇലക്ട്രിസിറ്റിനെ ഒരു ലോങ് ഡിസ്റ്റൻസ് സെൻഡ് ചെയ്യണം ത്രൂ കേബിളിൽ കൂടെ, വയറിൽ കൂടെ. രണ്ട് ഓപ്ഷൻ നമുക്കുണ്ട്. ഒന്ന് 20,000 വോൾട്ടും മറ്റേത് 200 വോൾട്ടും. വിച്ച് മെത്തേഡ് we should prefer? If you send electricity through 20,000 volt, what is the power consumption? 25 into 10 raised to 6 into resistance. Resistance, I am not finding out resistance. Why I am not finding out resistance? Because resistance will remain the same. See, പവറിന്റെ വാല്യൂ മാറിയാലും മറ്റേ വോൾട്ടേജിന്റെ വാല്യൂ മാറിയാലും റെസിസ്റ്റൻസ് സെയിം ആണ്. അപ്പൊ രണ്ടാമത്തെ കേസിൽ റെസിസ്റ്റൻസിന്റെ ഇക്വേഷൻ വാല്യൂ സെയിം തന്നെയാണ്. അപ്പോൾ രണ്ടാമത്തെ കേസിൽ വാട്ട് വിൽ ബി ദ പവർ കൺസ്യൂംഡ്? അഗെയിൻ ട്രാൻസ്മിറ്റഡ് പവർ ഈക്വൽ ടു വാട്ട്? വി ഇൻറ്റു ഐ. സോ പി ഈക്വൽ ടു വി ഇൻറ്റു ഐ. പി എത്രയാ? ഐ ഈക്വൽ ടു പി ബൈ വി. What is the transmitted power? Transmitted power is what? 100 into 10 raised to 6. In second case, what is the voltage? Voltage is only 200. So 100 by 200 means what? 1 by 2. So 1 by 2 is what? 0.5 into 10 raised to 6. Which means what? 5 into 10 raised to 5. That is the current. Now what is the equation for power? I squared R. See, I square means what? 5 into 10 raised to 5, the whole square, into resistance is what? R. 5 square is what? 25 into 10 raised to 5, the whole square is what? Into 10 raised to 10 R. See, in the second case, what is the power consumed? 25 into 10 raised to 10 R watt. So what happens? If you compare the first case, it is only 25 into 10 raised to 6. Here it is what? 25 into 10 raised to 10. So, if you send electricity at 200 volt, there will be 10 raised to 4 times more power consumption. 10 raised to 4 times more power consumption. More power consumption than how much? Than what? 20,000 volt. So if you send electricity at 200 volt, there will be 10 raised to 4 times power consumption than 20,000 volt. Here some students might be thinking, power is already given 100 megawatt. Then what power you are finding out here, sir? This is the transmitted power. And this is the consumed power. Or this is power loss. This power is what? Power loss. See, here also we are finding out what? Power loss. So power loss when the electricity is sent at a 20,000 volt is only 25 into 10 raised to 6. But when the electricity is sent at what? 200 volt, what is the power loss? 25 into 10 raised to 10. So there is a 10 into R. Here R I am not finding out. എന്തുകൊണ്ടാണ് മാഷ് R കണ്ടുപിടിക്കാൻ പോവാത്ത? രണ്ട് കേസിൽ R സെയിമാ. കാരണം ഞാൻ നാളെ പറഞ്ഞത് പവറും ഇവിടെ വോൾട്ടേജ് ഒക്കെ ഫ്ലക്ച്വേറ്റ് ചെയ്യും, പക്ഷേ നമ്മുടെ റെസിസ്റ്റൻസ് എന്തായിരിക്കും? സെയിം ആയിരിക്കും. അതുകൊണ്ടാണ് ഞാൻ 6 രണ്ട് കേസിലും 6 തന്നെ എടുത്തത്. 6 മാറുന്നില്ല. മനസ്സിലായോ? ആർ യു ഏബിൾ ടു അണ്ടർസ്റ്റാൻഡ് ദിസ്? ക്ലിയർ അല്ലേ? നമ്മളിത് മുമ്പ് പറഞ്ഞിട്ടുണ്ട്. ഇത്ര എക്സ്പ്ലനേഷൻ ആവശ്യമൊന്നുമില്ല. കാരണം നമുക്കറിയാം, നമ്മളൊരു ക്വസ്റ്റ്യൻ പഠിച്ചിട്ടുണ്ട്. വൈ വി സെൻഡ് ഇലക്ട്രിസിറ്റി അറ്റ് ഹൈ വോൾട്ടേജ്? ടു റെഡ്യൂസ് പവർ ലോസ്. മനസ്സിലായ എല്ലാവർക്കും? നോട്ട് ചെയ്യാട്ടോ, വേഗം നോട്ട് ചെയ്യാം, വേഗം നോട്ട് ചെയ്യാം. Done? Please try to say in English. I'm from Tamil Nadu. Anas. Okay, I will try. I will try. Majority of students are from Kerala, so that's why I have following Malayalam. Okay. Okay, I will try. Okay, done. I hope all of you done. So next problem. Two heaters are marked 200 volt, 300 watt and 200 volt, 600 watt. If the heaters are combined in series, heaters are combined in series, and the combination connected to a 200 volt DC supply, which heater will produce more heat? Which heater will produce more heat? Yeah. So, ഇവിടെ question എന്താ പറഞ്ഞേക്കണേ? Question has given us 200 volt, 300 volt, 300 watt, one case. So, one heater, let this be heater. First heater, 200 volt, 300 watt. Second heater is what? 200 volt only, but how much watt? 600 watt. If the heaters are combined in series, see, here power rating is different, voltage is same. So how to understand that? How to understand the resistance? How can you identify the resistance? We know that power is equal to V square by R. Here also power equal to V square by R. Now power is what? 300. Voltage is what? 200 square by R. So R is equal to 200 into 200 by 300. So answer is what? Answer is what? 400 by 3 ohm is the resistance in the first case. Second case, power is what? 600. Voltage is 200 only, 200 square by R. So R is equal to 200 into 200 by 600. The answer is what? Here it again what? 100. It becomes what? 3. So R equal to what? 200 by 3. In the second case, resistor. Now remember why I am going for resistance. See, for a device, resistance will be a constant. All other things will vary, but resistance will not vary. That is a very important point. Resistance will not vary. It's a very important point to understand. Now we got the resistance value. Now how they are connected? Combined in series and the combination connected to 200 volt. So it is connected in series means what? This heater is having resistance 400 by 3 and the other one is also what? 200 by 3. 200 by 3. Now the combination is connected to how much volt? 200 volt. Now what is the total resistance or equivalent resistance? It is what? 400 by 3 plus 200 by 3. That is equal to what? 600 by 3. That is equal to 200 is the total resistance. What will be the, that is the total resistance is 200. Now we have to find out which one will produce more, which one will produce what? More heat. So first of all, in order to get the amount of heat produced, we should use the formula power is equal to I squared R. So in order to get the current I, we should use what? Current I equal to, how to get current? Total voltage is what? 200. Sorry, total resistance is 200 ohm. I equal to V by R and voltage is what? 200 volt divided by 200 ohm. So I came to know that current in the circuit is 1 ampere. So remember, 1 ampere current is starting to flow from the positive terminal. When it reaches the first, let this resistor be R1 and let this resistor be R2. When the first current 1 ampere resistance reaches R1, power is equal to, what is the formula for power? Power is equal to I squared R. Why I am going for that formula? Because current value, resistance value both are given and current value is 1 ampere. So 1 square is 1, resistance is what? 400 by 3. So what is the power? 400 by 3 watt. And here what is the formula? I squared R only, but current is what? 1. 1 square itself is 1 square is what? 1. 1 square into 200 by 3, answer is what? 200 by 3 watt. So on first heater, power consumed is 400 by 3 and the second heater power consumed is what? 200 by 3. Which one is bigger value? Which heater will produce more heat? What is the answer? First one or second one? Which heater will produce more heat? Type your answers. First heater or second heater? Yeah, heater number 1. Therefore, first heater produces more heat. Now remember, whenever you get this kind of problem, you should first of all, you should have to find out the resistance, because voltage value, current value will fluctuate, but the resistance value will remain the same. Please note it down. Please note it down. Done? Kanya? Anjal, good evening. Done? Finish? Finish? Noted. Yeah. Next question. Again, same type NCERT problem. An electric bulb is marked 100 watt 230 volt. If the supply voltage drops to 115 volt, what is the heat and light energy produced by the bulb in 20 minutes. Heat and light energy produced by the bulb in 20 minutes. Calculate the current flowing through it. Calculate the current flowing through it. Calculate the current flowing through it. Let's see. Again, bulb is marked, power is what? 100 watt and voltage is what? 230 volt. It's easy, but better to find the resistance at that moment itself. So power equal to what? V square by R. R is equal to V square by P. So we will get the resistance of the bulb, which is 230 into 230 divided by 100. So which is what? 23 square, which is what? What is 23 square? 529. 529 ohm is the resistance. Now what happens when the voltage drops to 115 volt? So new voltage is what? 115 volt. Voltage drops to 115. We have to find out the heat energy produced in 20 minutes. Time is what? 20 minutes. That is, time is what? 20 into 30. That is what? Sorry, 20 into 60. That is 1200 seconds is the time. Now what I have to find out? The current flowing through it. Now remember, heat is equal to, first of all, you should know what is heat. Heat is equal to power into time. Now power is what? V dash square by R into T. Why V dash square? Because voltage dropped to 115 volt. Now remember, 115 into 115 divided by resistance is what? 529 into time is what? 1200. If you solve that, heat will be 30,000 joule. That means what? 30 kilojoule. Now current I is equal to what? So that is a heat energy. Now calculate the current we have to find out. Current I is equal to what? V dash by R. Why V dash? Because voltage drop. So 115 divided by 529. 529, that is a point. The resistance remains the same. For a device, for a particular device, its resistance remains the same no matter how much voltage is is applied to it, no matter how much current is flowing through it, resistance will remain the same. So 115 by 529, when you solve that, you will get 5 by 23 ampere. Directly writing the answer 5 by 23. So we have done heat and light energy, that is 30,000 joule, and the current, what is the current flowing through it? 5 by 23 ampere. Any doubts? നോട്ട് ചെയ്താ മനസ്സിലായോ? NCERT ടെക്സ്റ്റ് ബുക്ക് പ്രോബ്ലം ആണേ. നോട്ട്. Done, right? All of you done. Noted. Okay. Next, Kirchhoff's law based ചെയ്തിട്ടുള്ള പ്രോബ്ലം ആണ്. So let me tell you Kirchhoff's law. Kirchhoff's current law, what does it tell you? Total incoming current is equal to total outgoing current, or algebraic sum of currents meeting at a junction is what? 0. Kirchhoff's voltage law is what? Sigma ER is equal to sigma E. That is sum of voltage drop is equal to sum of voltage drop equal to sum of EMF. Sum of voltage drop is equal to sum of EMF. That is Kirchhoff's voltage law and current law for you. Now we are going to do problems based on Kirchhoff's voltage law and current law. Let's see. I'm directly drawing the figure. Is 60 ohm plus or minus 4 volt. This is 20 ohm minus plus 200 ohm. Current is given I, and this is I minus I1, and this current is what? I1, and here the potential is EMF is 5 volt, and this corners are PQRS, and this current is I. This current is I minus I1. This current is I minus I1, and this current is I. Yeah, okay. What is our task? We have to find out the value of I1. Very simple question. We have to find out the value of I1. Where is I1? Yeah, we have to find out the value of I1. See, it's a resistor network. Resistors are there, cells are there. We have to solve this circuit and find out the value of I1. So we have to use Kirchhoff's law. Kirchhoff's voltage law is the law which I am going to use. Let's see, applying Kirchhoff's voltage law to the loop PRSP. Now, what is the current through PR? I1. So, what is the voltage drop? Whenever in electrical circuits current meets resistance, there will be voltage drop. ഇലക്ട്രിക്കൽ സർക്യൂട്ടിൽ എപ്പോഴൊക്കെ കറണ്ട് റെസിസ്റ്റൻസിനെ കണ്ടുമുട്ടിയോ അപ്പോഴൊക്കെ വോൾട്ടേജ് ദർ വിൽ ബി വോൾട്ടേജ് കൺസംഷൻ. ക്വസ്റ്റ്യൻ എന്താണ്? ക്വസ്റ്റ്യൻ I1 വാല്യൂ ക്വസ്റ്റ്യൻ മാർക്ക്. യു ഹാവ് ടു സോൾവ് ദിസ് സർക്യൂട്ട് ആൻഡ് യു ഹാവ് ടു ഫൈൻഡ് ഔട്ട് ദ വാല്യൂ ഓഫ് I1. Okay, Kirchhoff's voltage law to the loop PRSP. So when you consider the branch PR, what is the current in that branch? I1. What is the resistance in that branch? 20. So 20 I1. Now we have reached from P, we have reached R. Now which order I should go? From R to S. What is the current in the branch R to S? I minus I1. So minus 20 into I minus I1. Minus, not 20, 200 into I minus I1. Minus 200 into I minus I1. Why there is minus sign? Because I am traveling from R to S and the current is coming opposite to me. Whenever current is in the opposite direction, you have to give minus sign. So that is the reason why I have given minus 200 into I minus I1. Why? Because when I travel from R to S, current is coming opposite to me. Now I have reached S. Now from S to P I am traveling. See, there is no resistance in S to P branch. So there is no voltage drop in S to P branch. But there is EMF in that branch. What is EMF? 5 volt. See, when I traverse through a current carrying loop, and if I am seeing negative side of the cell first, you have to give plus sign to the EMF. And if you are seeing positive side of the cell first, then you have to give minus sign to the EMF value. So this is the first equation. Now when I see this equation, I can see that the equation can be divided by 5. So it becomes what? 20 by 5 is what? 4I1 minus 200 by 5 is what? 40 into I minus I1 is equal to 1. So 4I1 minus 40 into I minus I1 is equal to what? 1. Okay, now next side, applying. So I got one equation, applying Kirchhoff's voltage law to the loop. So next I am going to take the loop PRQP. PRQP. So at first I am traveling from P to R. So 20 I1, because I1 is the current and resistance is 20. So 20 I1. Then I am traveling from R to Q. So plus 60 I. Then I am, okay. So these are the only two voltage drop. See, in this branch QP there is no resistance, so there is no voltage drop. So, but since I am seeing when I travel from Q to P, because the order says to me that I should travel in the path Q to P, I am giving minus sign first, so I should write what? Minus 4. Minus 4. Sorry, minus sign first, so plus 4. Any doubts? So if you divide it by 4, what do you will get? 5I1 plus 15I is equal to 1. Any doubts? Any doubts in framing this equation? I am marking this as equation 1 and this as equation 2. Any doubts? Any doubts? Please respond. Here we got two equations. Now we have to simplify these equations somehow. So how to simplify this equation? So it should be at a common format. So I am multiply equation 1 into 8. So what you will get? 32I1, not 8, I think with 3. equation 1 into 3. That means what? 12I1 minus 40. Instead of 40, I should write what? 1, 2. Now, before that, I think I should remove the bracket. So, I am writing 4I1 minus 40I plus 44I1 is equal to 1. Then, second case, what is equation? Now, how it changes? See, in the second case, 4I1 is there, 44I1 is there. So, it becomes what? See, here 4I1 is there, then what? 44I1 is also there. So, 4I1 plus 45I1 is what? 48I1 minus 40I is equal to 1. And the second case what? 5I1 plus 15I is equal to 1. So, 48I1 minus 40I is equal to 1. 5I1 plus 15I is equal to 1. So, here we have two equations. Okay. Any doubts? Any doubts? I think some of you are not able to follow this. What is the potential here? 5 volt, and here I minus I1 current 200 ohm, and here it is 20 ohm. So what we are doing? We are simply taking a loop, PRSP. PRSP. What is the resistance in PR branch? 20 into current is what? I1. Then what? Minus 200 I minus I1, because this current is in the opposite direction of our traveling. We are traveling from R to S. So minus 200 into I minus I1 equal to 5. So when you cancel, divide it by 5, how much you will get? 4I1 minus 40 into I minus I1 is equal to 1. We dividing it throughout by 5. 20 by 5, 4. 200 by 5, 40. Now, second loop means what? PRQP. So, 20I1 in the same direction and 6 plus 60I equal to what? Since you are traveling, seeing minus sign first, plus 4. Since you are traveling, minus sign first, plus 4. Okay. So, dividing throughout by 4, how much we will get? 5I1 plus 15I is equal to 1. So, then now expanding, you got what? 4I1 minus 40I plus 44I1 equal to 1. That is 48I1 minus 40I is equal to 1. Now, you got two equations. Let this be equation 3 and equation 4. I am multiplying equation 3 into 4. Equation 3 into, no, I think equation 3 into 3 is enough. So, 48 into 3 means what? 48 into 3 means what? Here, 40 into 3, 120I, and here it's 3. 40 into 3, 120, 8 into 3, 144I1. Here, equation 4 into how much I should multiply? In order to get the same 120, I am multiplying with the 8. So, 5 into 8, 40I1 plus 15 into 8, 120I is equal to 8. So, I am adding these two equations. Let this be equation 5 and equation 6. By adding equation 5 plus 6, what you will get? 140 plus 140I1 plus 40I1. 184I1 is equal to 11. So, I1 is equal to what? 11 by 184. I1 is equal to what? Not 144. Here, 48 into 3, right? So, once, what is a mistake from my side? 40 into 3, 120. 8 into 3, 24. Yeah, same one. 40I1 plus 120. Yeah. 44 in question 1. 1 equation 3. So I think there is some mistake. 4I1, 44I1. എനിക്ക് കിട്ടുന്നില്ല. 4I1 minus 40I plus 44I1. So 48I1 minus 40I equal to 1. So 48 into 3. Where I have done wrong? Sir, it is from brackets is mistake. 40I minus 40I1. Here I have written 44I1. Yeah. 40I plus 40I1. So it becomes, here it becomes what? 44I1. 4I1 plus 44I1. So here it becomes what? 44 into 3. That is 132I1. Yeah. 132I1. So here it becomes what? 172I1. So I1 is equal to 11 by 172 ampere. So thank you. I was really confused there. Yeah, I think a bracket, when I removed the bracket, no, there was a mistake. Instead of 40I, I had written 44I1. It should be 40I1. I calculated 40I1 with the 4I1 and I had written 44I1 there, which was wrong. Now I have corrected it. 11 by 172 is the right answer. I hope all of you got that. Any doubts? It's a very important problem. Any doubts? 11 by 172. All of you got it? All of you got it? Yeah. Noted? All of you noted? Please note fast. It's a very important problem. ഭയങ്കര ഇമ്പോർട്ടൻ്റ് ആണ്, എസ്പെഷ്യലി CBSE സ്റ്റുഡൻസിന്. സ്റ്റേറ്റ് കിർച്ചോസ് കറണ്ട് ലോ, സ്റ്റേറ്റ് കിർച്ചോസ് ലോ, വോൾട്ടേജ് ലോ, ദെൻ സോൾവ് ദ ഗിവൻ സർക്യൂട്ട്. അങ്ങനെ ക്വസ്റ്റ്യൻ വരും. കിർച്ചോസ് കറണ്ട് ലോ സ്റ്റേറ്റ് ചെയ്യുക, കിർച്ചോസ് വോൾട്ടേജ് ലോ സ്റ്റേറ്റ് ചെയ്യുക, എന്നിട്ട് ഈ സർക്യൂട്ട് സോൾവ് ചെയ്യുക. ആ ടൈപ്പ് ക്വസ്റ്റ്യൻസ് റിപ്പീറ്റഡ് ആയിട്ട് കാണാവുന്ന ക്വസ്റ്റ്യൻസ് ആണ്. സ്റ്റേറ്റിൽ അങ്ങനെ കണ്ടിട്ടില്ല. സ്റ്റേറ്റിൽ ഇക്വേഷൻ ഫ്രെയിം ചെയ്യാനേ വരാറുള്ളൂ, സോൾവ് ചെയ്യാനായിട്ട് അങ്ങനെ വരാറില്ല. Done. I hope all of you have done. Please finish fast. If you are not finished, please finish fast. Done? Okay, done. The next problem. ഞാൻ കിർച്ചോസ് ലോ തന്നെ ഒന്നുകൂടി ചെയ്യാം കേട്ടോ. 5 ohm, then 2 ohm plus minus plus minus 6 volt, 3 ohm, current I2, here current I3 plus minus current I1, and here 12 volt, this is junction F, junction E, junction D, not junction, corner D, C, B, A. These are the data given. What we have to find out? Find out the value of I1, I2, I3. I have to find out the values of all the current I1, I2, I3. That is my task. Okay, let's see. Applying Kirchhoff's voltage law to the loop A, B, E, F, A. ഞാൻ ചുമ്മാ ഒരു ലൂപ്പ് എടുത്തു A, B, E, F, A. Now listen, when you see this figure, കുട്ടികൾ വിചാരിക്കും, students will think that there is no current which is flowing through AB. It's a tricky one. See, in the branch FA, the current is I1 and A is not a junction. See, a straight wire FAB is bent and the wire is, this point is F, this is A, this is B. It's a straight wire only. It is simply bent. It's not a junction. So even though the current through AB is not given, you should understand that current through AB is what? I1. You should understand that current through AB is what? I1. Current through AB is what? I1. But there is no voltage drop in AB. Why? Because there is no resistance. Now current through BE. See, the incoming current at the junction B is I1, and to junction B again I2 current is also coming. See, DC branch current is I2 and C is not a junction. It's a straight wire only which is bent. So it is understood that branch CB is also having current I2. So I can say that at the junction B, who are the incoming currents? I1 and I2. I1 plus I2. And what is the outgoing current? I3. Okay, let's see. So AB branch, no voltage drop. Even though there is current I1, resistance is not there, so no voltage drop. In the BE branch, current is I3 and the resistance is 2 ohm. So voltage is what? 2I3. Now in the EF branch, what is the current? I1. In the EF branch, what is the current? See, so again some students will be thinking EF branch there is no current. See, F is not a junction and current in FA is I1, which is clearly understanding that, common understanding that the same current has to travel through E to F because F is not a junction. If FA current is I1, it is very easy to understand that EF current is also what? I1. So 2I3. But EF branch, there is no voltage drop because even though current I1 is flowing there, there is no resistance. See, the current, it is not mentioned in the question that current I1 is flowing from E to F. But it is our common understanding is that there is current I1 in EF branch, but there is no voltage drop since there is no resistance. Now again FA branch, what is the specialty? Current is what? I1 current is flowing and the resistance is what? 5 ohm. So 5I1. Now one more point, in the FA branch I am seeing negative terminal of the cell first. So I should write 12 plus 12. So 2I3 plus 5I1 is equal to 12. I hope all of you it's clear. Now applying KVL to the loop. What is the next loop? BCDEB. What is the current in BC? I2. But there is no resistance, so no voltage drop. In the branch CD, resistance is 3 ohm. So we are traveling from C to D, but the current is coming opposite. So I am writing minus 3I2. So whenever you see current in the opposite direction of your travel, you have to give minus sign. And you are seeing positive terminal of the cell first. So it should be what? Minus 6. Then D2E, any current is there? Yes. What is that current? Since DC branch is I2, ED branch also should have the same current because D is not a junction. If it was a junction, current might be different. Now I am going from E to B in order to complete the loop. So what is the current in E to EB branch? I3. But since I am going from E to B and the current is from B to E, I should give what? Minus 2I3. Now I know that I3 equal to I1 plus I2. So 2 into I1 plus I2 plus 5I1 is equal to 12. And minus 3I2 minus 2 into, instead of I3 again I am writing I1 plus I2 is equal to minus 6. So 2I1 plus 2I2 plus 5I1 is equal to 12 when you expand the bracket. So 2I1 plus 2I2 plus 5I1 is what? 7I1 plus 2I2 is equal to 12. Now in this case minus 3I2 minus 2I1 minus 2I2 is equal to minus 6. Minus 3I2 minus 2I2 minus 5I2 is equal to, minus 2I1 is equal to minus 6. Minus 3I2 minus 2I2 minus 5I2 minus 2I1 equal to minus 6. So minus 5I2 minus 2I1 is equal to minus 6. Any doubts? Sir, opposite direction check cheyan pattumo? Yes, Navneet, you can do in the opposite way. Because some teachers teach students in the opposite way. In either way you do the same problem, you will get the same answer. No problem. Direction is up to you to decide. No problem. So these are the two equations which we got. What are these equations? 7I1 plus 2I2 is equal to 12. Minus 2I1 minus 5I2 is equal to minus 6. Now we have to bring it in a common format. So it's better to multiply. Let this be equation 1 and let this be equation 2. Equation 1 into 5. Equation 1 into 5 means what? 35I1 plus 10I2 is equal to 60. And equation 2 into 2. So minus 4I1 minus 10I2 is equal to minus 12. Please check. ഒന്ന് ചെക്ക് ചെയ്തോളട്ടെ. ഞാൻ ചിലപ്പോൾ ചെയ്യുമ്പോൾ സില്ലി മിസ്റ്റേക്സുകൾ വരുത്തും. പിന്നെ എല്ലാം കഴിഞ്ഞിട്ട് അവസാനം നോക്കുമ്പോൾ കിട്ടൂല. ഒന്ന് പറഞ്ഞോളൂ, കറക്ഷൻ ഉണ്ടെങ്കിൽ പറഞ്ഞോളൂ കേട്ടോ. അപ്പോൾ ഇത് ഇക്വേഷൻ 3 ഇക്വേഷൻ 4. അപ്പോൾ നമുക്കൊരു കാര്യം ചെയ്യാം, 3ഉം 4 ആഡ് ചെയ്യാം. ഇക്വേഷൻ 3 പ്ലസ് ഇക്വേഷൻ 4. അപ്പോൾ 35I1 പ്ലസ് മൈനസ് 4I1 എത്രയാ? 31I1. ഇത് 0 ആയി. 60 പ്ലസ് മൈനസ് 12 എത്രയാ? 58. സോ I1 is equal to 58 by 31. I1 equal to 58 by 31. അല്ല ഞാൻ എന്ത് പൊട്ടന 60 minus 12 48 അല്ലേ 48 by 31. അണക്കേടാണല്ലോ ഇതൊക്കെ തെറ്റിക്കണ 48 by 31. Okay, so that was I1 value. I2 and I3 value I am writing. If you solve that, you will get I2 is equal to 18 by 31 and I3 as 66 by 31. 66 by 31. You can give the value, no? When you get this value, you can give it in any equation and you can solve. കിട്ടിയ മനസ്സിലായ മക്കളെ? മനസ്സിലായ? ഇമ്പോർട്ടൻ്റ് ആണ്, എൻട്രൻസിന് ഇമ്പോർട്ടൻ്റ് ആണ്, CBSE-കാർക്കും വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്, സ്റ്റേറ്റുകാർക്ക് അത്ര ഇമ്പോർട്ടൻ്റ് അല്ല, അങ്ങനെ ചോദിക്കാറില്ല. കിട്ടിയ എല്ലാവർക്കും നോട്ട് ചെയ്യട്ടോ. കിട്ടിയ നോട്ട് ചെയ്തോ? നോട്ട് ചെയ്യാം. നോട്ട് ഇടുന്ന ആരെല്ലാം എഴുതിയാ നമുക്ക് അടുത്ത ക്വസ്റ്റിലേക്ക് ചെയ്യാം. ഞാൻ നോട്ട് ചെയ്യാൻ വേണ്ടി വെയിറ്റ് ചെയ്യുന്നത് നിങ്ങൾ. നോട്ട് ഡൺ കഴിഞ്ഞില്ലേ? ശരി, ഞാൻ ഇതിൻ്റെ ഒരു ടൈപ്പും കൂടി ചെയ്യാൻ പോവണേ. നോട്ട്. ഓക്കെ, അടുത്ത ക്വസ്റ്റ്യൻ പറയാം. പ്ലസ് മൈനസ് 2 ohm (4 ohm) plus minus here it is 1 ohm, 12 volt, 6 volt. This is E1 and this one is E2. ഓക്കെ, ഇങ്ങനെയാണ് സംഭവം. നമുക്കിത് പറയാൻ പറഞ്ഞേക്കണത് we have to find out potential difference across 4 ohm. 4 ohmനെ ക്രോസ് ഉള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ് ആണ് കണ്ടുപിടിക്കേണ്ടത്. അതിന്റെ അർത്ഥം പറയുകയാണെങ്കിൽ 4 ohmiൽ കൂടെയുള്ള we have to find out now how can we decide whether B is a junction, sir? Sweda, I don't know who is Sweda. Okay, how can you, what is the doubt? How can we decide whether B is a junction? See, you can clearly see that, no, whenever you see more than one path, it's a junction. Sweda, where is your house? മോളുടെ വീട് എവിടെയാ ശ്വേത? ശ്വേതയുടെ വീട് എവിടെയാ? Yeah, okay. You are from Coimbatore. See, I remember Coimbatore railway station is a junction. It's because there are separate routes from Coimbatore. So it's a junction. But I hope you have been to Trichur, where we are taking class. Trichur is not a junction because there is one incoming line and one outgoing line, no other lines. So whenever there is more than one path, then we call it as what? Junction. Coimbatore railway station is a junction. Thrissur is not a junction. See, A is not a junction because there is only one path. But B, there is this path, and so there is, when you consider B, there is a path which is ABC, and another path is what? ABE, and another path is what? CBE. So B is a junction. Is C a junction? No, there is only one path. What is that? BCD, or you can say DCB. There is only one path. Then E is a junction. Yeah, obviously is a junction because to that E junction, I3 is the incoming current, I1 and I2 are the outgoing current. Again, you can apply Kirchhoff's law at the junction E. At the junction E, what happens? I3 is equal to I1 plus I2. Incoming current is equal to sum of incoming current is equal to sum of outgoing current. Any doubt? Seda, is it clear? B junction, E junction, is there any other junction? No, only two junctions in the circuit. Clear, no? Sweta, thank you for asking doubt. Always clarify your doubt. Okay, now voltage across 4 ohm, I have to find out voltage across 4 ohm. Now, how to do this? Now, why I have given this problem? But the specialty of this problem is that in generally Kirchhoff's problem, the current value I1, I2, I will be given. But this is a special type of problem where currents are not given. So simply you have to take currents. So I am E1, E2 is there. So since it is E1, I am marking this current I1. And since it is E2, I am marking this current as I2. Now Sweda, see, whenever, again I am repeating, see, in the original problem, current is not given. So that is the reason why I call it a special case. So Sweda, since there is EMF E1, I am supposing that, I am thinking that, okay, let current I1 comes out of this positive terminal of the cell, and from E2 current I2 is coming. See, I1 current is coming to this junction, I2 current is coming to this junction. So which current leaves the junction? I1 plus I2. Don't write I3. Even if you write I3, it's correct only, but it means what? An additional variable will be there. So instead of writing I3, I am writing I1 plus I2. Is it clear, Sweda? And before that, you have to give names A, B, C, D, E, F. Now Sweda is coming to know that at the junction F, I1 current is coming and also I2 current is coming to the junction. So this branch has to what? Should contain the outgoing current. So instead of writing I3, Sweda is writing I1 plus I2. Sweda, is it clear? Yeah. So let's see. Now I have given the name, so it's easy for me to apply the Kirchhoff's loop rule. Applying KVL to loop A, B, C, F, A. 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 AB branch current is what? AB branch current is, I am traveling from A to B, current is coming opposite. So I am giving AB branch current as what? Minus I2. AB branch current is what? minus I2. Why I am minus I2? Because I am traveling from A to B, current is coming opposite to me. Minus 1 into I2, which is minus I2. Resistance is 1, current is I2, so minus I2. Since I am seeing the positive terminal of the cell first, I should write minus 6. If it was negative, it should be plus 6. Now I have reached B, then B to C. So this is the way I am supposed to go. A, B, C, F, A. Now what is the current in BC? First I thought there is no current in BC. Then I remembered what my teacher told me. Because if AB branch is having the current I2, and since B is not a junction, the BC branch also should have current I2, which is not given in the question. I am adding that. But there is no voltage drop. Why? Because there is no resistance. If there is resistance, then only there will be voltage drop. Then I am moving from C to F. Okay, C to F means what? C to F. C to F means what? I am traveling from C to F, but current is coming opposite to me. So I should give minus sign. So minus 4 into I1 plus I2. Minus 4 into I1 plus I2. Now I have reached F. Minus 4 into I1 plus I2. I have reached F. Okay, now I got that. I have reached F. Now let's see. Now what happens? Minus I2 minus 4I1 minus 4I2 is equal to minus 6. That is minus 5I2 minus 4I1 is equal to minus 6. Okay, throughout there is minus. So I can write 5I2 plus 4I1 is equal to plus 6. I am removing minus throughout. So that is one equation. Now another equation, applying Kirchhoff's voltage law. You can take it in any order. Don't think that the order which I am taking is the only option. You can take any other way. I am writing FE DCF. FE DCF. What is the current in FE? First I thought no current. Then I came to know that D branch is having current I1. So I1 current has to travel through FE. But there is no voltage drop. Since I am traveling from E to D and I am seeing positive terminal first, I should give minus 12. Then I am seeing 2 ohm, 2 into resistance, 2 into current I1. First I thought plus 2I1. Then I came to know that I am traveling from E to D and the current is coming opposite to me. So I have to give minus sign. So minus 2I1. And then I thought there is no current in DC branch. Then I came to know that if ED branch is having current I1, DC branch also should have current I1. Then CF branch, what is the current? CF branch. I am traveling from C to F, but the current is coming opposite to me. So 4 into I1 plus I2 again. So minus 2I1 minus 4I1 minus 4I2 is equal to minus 12. That means minus 6I1 minus 4I2 is equal to minus 12. So again I can remove minus throughout. So 6I1 plus 4I2 is equal to 12. So that means it is commonly we have 2. So 3I1 plus 2I2 is equal to 6. 3I1 plus 2I2 is equal to 6. So I got two equations. Let this be equation 1 and let this be equation 2. Can we simply add them? No, we can't do that. So let equation 2 into equation 2 into, I think I should be writing in the correct order. A little better. Better to write 4I1 plus 5I2 is equal to 6. And the second one, 3I1 plus 2I2 is equal to 6. So first equation into 2. First equation into 2 means what? 8I1 plus 10I2 is equal to 12. And second equation into 5. So 15I1 plus 10I2 is equal to 30. Equation 3, equation 4. Equation 3 minus equation 4 means what? 8 minus 15I1. So minus 7I1. 0 equal to 12 minus 30 is what? Minus 18. So I1 equal to what? 18 by 7. I1 is equal to 18 by 7. How you decide the loop paths are? There is nothing. You can simply take randomly. You can say, sir, I will follow FCBAB, BAF. No problem. Sir, some Sweda is saying, sir, I will go through only CBAFC. Then also no problem. You can choose whatever be the path you can choose, no problem. Just follow the rules. Current is coming along with you, plus sign. Current is coming opposite to you, minus sign. If you are seeing positive terminal of the cell first, then EMF value should give minus sign. If you are seeing negative side of the cell first, then you should give positive value for the EMF. Just follow that rule. Nothing else. You can choose any order, no problem. So I1 equal to what? 18 by 7. Now I have to find out I2. I'm just writing the value. I'm not wasting time. I2 equal to minus 6 by 7. If you solve that, no, you can give the I1 value to any equation, then you will get I2. I2 equal to minus 6 by 7 ampere. If you solve that, you will get the answer. Now I got I1, I2, but that is not the case because we have to find out potential difference across 4 ohm. What is potential difference? Current into resistance. What is current? I1 plus I2 into resistance is what? 4. What is I1? I1 is what? 18 by 7 minus 6 by 7 into 4. So that means what? 12 by 7 into 4. That is what? 48 by 7. If it was 49 by 7, then would have been 7. So it might be 6.9. by 7, that is 6.9 volt. Any doubts? 48 by 7. Ohm, not ohm. We are finding potential across 4 ohm. 48 by 7 volt, not ohm. Navneet, correct it. Any doubt? Yeah, 48 by 7 volt. Done. Please note it down. നിങ്ങൾക്ക് മനസ്സിലാവണില്ലേ മക്കളെ? ഇത് ഇമ്പോർട്ടൻറ്റ് പ്രോബ്ലം ആണ് എൻട്രൻസിന്. ഇമ്പോർട്ടൻ്റ് ആണ്. I hope all of you are understanding. Please respond. It's a lengthy problem. I hope all of you are understanding. എല്ലാവർക്കും മനസ്സിലാവണില്ലേ? Noted? All of you noted? Done, right? Clear, noted? Please respond, all of you noted? Okay, I hope it is done. Okay, let's continue. Next, Wheatstone type of problem. I hope you remember Wheatstone bridge is an arrangement of 4 resistors, out of which 3 are non-resistors and 1 is an unknown resistor. By connecting them in Wheatstone way, we can find out the value of unknown resistance. And remember, balanced condition. Under balanced condition, no current flows through the middle branch. See, this is a Wheatstone problem which I am going to do now. This is R. This is 100 ohm. (200 ohm). (100 volt). See, this is 200 ohm. This is 40 ohm. This is what 100 ohm. See, we have to find out the value of the resistor R. See, that is our task. We have to find out the value of the resistor R. Now, since it's a 4-branch arrangement, we know that most probably it might be Wheatstone. Then students will be thinking, sir, balanced condition is not given. Then how can you solve that? But actually, balancing condition is given. You have to understand that because galvanometer needly standing straight. That means what? No current is flowing through the middle branch. That means what? Balancing condition is given. That means what? Balancing condition is given. So that means what? Upper branch is equal to ratio of resistance in the upper branch is equal to ratio of resistance in the lower branch. See, P, Q, the whole combination of 2 resistors is Q, and this is what? R, and this is what? S. So P by Q, that is 100 divided by 100R divided by 100 plus R. Why I am writing that? Because this is R1 R2 divided by R1 plus R2. Why I am taking that? Because it's a parallel combination. If you solve Q resistor value, what is the formula? R1 R2 divided by R1 plus R2. The whole answer comes under or in the numerator of P by Q, because balancing condition, I hope you remember that P by Q equal to S by R. So instead of P I am writing 100, instead of Q I am writing 100R divided by 100 plus R. Instead of S I am writing 200, and instead of R I am writing 40. So what happens? 20 by 4 is what? 5. So 100. Then denominator 100 plus R goes to numerator. So 100 plus R divided by again 100R. So 100 gets cancelled. So 100 plus R by R is equal to 5. So 100 plus R is equal to what? 5R. So 100 is equal to 5R minus R. That is 100 is equal to 4R. So R equal to what? 100 by 4. R is equal to 25 ohm. Any doubts? Manasilayo? Sweda, is it clear? Anas, is it clear? Ismaya, good, very good. Navneet, very good. Sweda, Anas, if you are not having the idea of Wheatstone bridge, first of all, you have to go through the Wheatstone class. Then only you will get an idea about this. I think Sweda might not attended that class. Any doubts? Yeah, Anas, good. Please note it down. It's a very important problem. Done, noted. Others noted? Now one more point. I had already told you that in Wheatstone type of problem, if all branch excluding the middle branch have the same value, then total resistance will be equal to what? Suppose these are this arrangement, let this be A, let this be B. What is the resistance between A and B? What will be the resistance between A and B? We have discussed this. R, very good, Navneet. If excluding middle branch, all resistors are having same, all branches are having same resistance. That means total resistance equal to what? Resistance of any one branch. So what is the answer? RO. Yeah, you have attended. Good. Seda, I hope you remember. In Wheatstone type of problem, if all branches excluding middle branch have the same value of resistance, then the total resistance equal to what? Resistance of any one branch. So what is the answer? R ohm. Okay. Yeah. Remember, next class is a revision class of the first 3 chapters. Next class is a revision class of first 3 chapters. We will be doing problems from first 3 chapters. From by the end of tomorrow's class, we will be finishing all the 3 chapters. Next week, we will be starting the 4th chapter. Okay. Got it, right? So, thank you. Thank you. Good night. Thank you.